Hi, welcome to the part tangent and normal. Now in this part, as I have already said, the first thing to know is what is a tangent and what is a normal. Now the most important thing is you are aware what a tangent is, right? Basically it is the tangent is something, let's say there is a curve like this and my tangent is just eclipsing it, that is touching it. So you are aware of the tangent. Normal is perpendicular to a tangent at the point of intersection. So in this part we will be looking at tangents and normals and its different variations, finding out how many normals are there, finding out how many tangents are there based on the application of derivative, first derivative as well as second derivative. Okay?
Now, in this next part, we'll be studying about tangents and normals. Up till now, you have studied about its properties and different criterias, what are tangents and what are normals. Now, over here, we will be looking at how they exist. Okay, till now you might be knowing that okay, a particular tangent is written in this form, a particular normal to a particular value is written in a different form. But how do they come? If we use calculus, and using calculus if we calculate tangent and normal, how do we arrive to that? Now for tangents and normals, it's very simple to study. What are tangents? Now if you look at this plane figure, okay, this is nothing but a tangent, right? And this line, green one, is my tangent and this is my normal. Now in simple denominations, t is represented by tangent and n represents my normal. Alright, so this is a common phenomenon that you will be finding everywhere. Okay, in exams also the equations will be given like t as x minus y is equals to 4, like these forms. Okay, and normal accordingly will be like say 2x plus y is equals to 8, something like that. Now the important interesting thing to know is that p is perpendicular to n, or n is perpendicular to my p. Okay, so both of them will always make a 90 degree. If let's say this tangent was somewhere over here like this, then my normal would have been like this. So this is a basic understanding of tangents and normal to a tangent. Now coming to the next part, we know the definition. A tangent to a curve at a point is a straight line that just touches the curve at that point. Okay, and normal to the curve is a point is a straight line that is perpendicular to the tangent at that point. Simple straight definition. Now important things to know over here is, first of all, we can use differentiation to find the equation of the tangent. Now if we know to do that, we can obviously find the normal. Why? Since both of them p is perpendicular to normal, the only difference will be the equations would be same, only the slope would be inverse, right? Then negative inverse. In both the equations, the slope is the only factor that will differentiate them, right? As we know, if we have perpendicular cases, the slope is the negative inverse of one another. Okay, now let's look at an example. Okay, now let's say I have an equation of the tangent and the normal to the curve, this at this point. Okay, now my equation says I have y is equals to x square minus 5x plus 8, right? Now I differentiate this, right? This is my y dash, also known as dy by dx. This will come out to be 2x minus 5, right? Now I have at this point p3 comma 2. Okay, in this term I will have my x is equals to 3, right? So for this one, my value is coming to be 2 into 3 minus 5 is equal to 1, right? Now also I know that y minus y dash is equal to m into x minus x dash is the equation of a line, right? Now this over here 1 is what? This is my gradient, right? Also known as the slope, right? Is 1. Okay, so for normal I will have my m is equals to 1 and my y dash is represented by this point. X dash and y dash I'll get from this. So my equation becomes y minus 2 is equals to 1 into x minus 3. Solve this and I will have y minus x is equal to minus 1 will be the equation, right? So this is the equation of the tangent. Okay, so like this way only we will find out the perpendicular inverse would be the equation for the normal. Alright, so this is the question. Simple, plain enough. Moving on, let's study tangents individually. What is it? Let's say I have a function fx. Okay, it is continuous for the curve, let's say between these given points. Alright, then the slope of this tangent is given by f dash. Just now we solved this, right? We took out the gradient and this is how we got that, right? At this given point. So the equation of the tangent to the curve becomes this one, just the equation I solved, right? So this is how we find out the tangent. Now how do I take normal? Normal comes as normal is perpendicular to the tangent, just as discussed. I have it in this form, right? Then the slope of the normal is the negative of inverse of the slope of the tangent, that is this is 1 over here, right? We are aware of this point. Let's say if my slope of t is m, then the slope of n would be minus 1 by m, right? So using this only, I'll take out the equation of the normal also in the previous question. Okay, now the equation of the normal hypothetically then becomes this one. Only difference is yeah. Alright, now let's come to an interesting part. Now let's say I have two curves. Alright, I have my two curves which intersect like this. Okay, like let's say for circles, two circles which intersect. Alright, there has to be an angle, right? If they are intersecting, then it intersects at a particular angle. But we have never thought that when we have curves, how do I take out the angle? So since now we have studied tangents, we now know the difference, right? What we can do is we can put tangents over here and we will study that, right? Let's see how. Okay, similarly you see this is my one curve and this is my second curve, let's say C1 and C2. Okay, now you see this is one tangent, right, and this is the other tangent. For this curve I have this as my tangent and for this curve I have this as my tangent. Now these two lines, when they intersect, they can give me a proper angle termed as theta. Now if I extend that and plot it on an xy graph, then I can have it from a property, right? Let's say this is the point of intersection x0, y0. These are the two equations of the curves. I can get my theta. See, the sum of these two angles will be equal to this, right? Property that we studied in 9th and 10th grade, right? The exterior angle is the sum of the interior opposite angles, okay? Or the sum of the interior angles is equal to the exterior opposite angle, right? So based on that I can get this. If I put tan both the sides, what do I have? I get this from trigonometry. I know this formula, right? Tan A minus tan B is equal to tan A minus tan B. by 1 plus tan A tan B, right? Now if from the definition of slope, I know that my tan theta 1 is equal to f dash x naught, right, which is my slope of m1. Similarly, I have my slope of m2 because for theta 2 I have g dash x2, right? So this will give me m2. Now, so what does this change do? This equation now comes in terms of the slope. So conversely, my equation finally becomes like this. Will come to that part. The other angle is 180 minus q, right? The second angle. The orthogonal curves, this is what they become. m1 into m2 is equals to minus 1. That is when they are perpendicular, right? When the two curves meet at a perpendicular, then their m1 m2 will be like this. Curves touch each other, then it will be like this. Alright. So conversely, what does that give me? That gives me a formula where my tan theta becomes m1 minus m2 by 1 plus m1 m2. Okay, this is just a fact to remember. Okay, now let's look at my first example. I have to show that this curve x2 is equal to this and this intersect orthogonal. Now straight, if I look directly, I know the solution, right? I have just studied this. How do I solve this? I know how to get the solution, but how to come to that part? Okay, look at this. I have my two equations. Okay, I will write it as 4y is equals to x squared and 4y is equals to minus x squared plus 8. What do I do in both the cases? In both the cases, I will differentiate with respect to x. So this will give me 4 dy by dx is equals to 2x dy by dx, right? Also, this will become 4 dy by dx is equals to minus 2, right? So these are the two equations that I am getting. Conversely over here, so I will have this from here. I have my dy by dx is equals to x by 2, and over here I'll have my dy by dx is equals to minus x by 2. Simple. Now I know this becomes my m1, right, and this one becomes my m2, the two slopes. Okay, now m1 into m2 is equal to how much? Let's do that, and I get that it becomes minus 1. Alright, so now how do I calculate this? Okay, now this is at x naught y naught. Remember, x naught y naught. I have the value of x given here. So from that I'll get my m1, which is equals to 1, and my m2, which will become minus 1. So from m1 m2 I have my minus 1, which satisfies the condition of orthogonality. Alright, so hence I have at this given point the two curves are orthogonal. Clear? Plain and simple, nothing. Differentiate them with respect to x, and at the point of x naught y naught I put the value of x to get the two values of the two slopes, multiply them, and it satisfies the condition of orthogonality. Alright, so this was the simple example based on orthogonality. Next, you see, this is exactly how I have solved it. You see, simple. You see, the value is here and the value is here, and this is my orthogonality. Alright, so they are orthogonal to each other. Let's look at the next example. Now I have a man 1.6 meters high walks at the rate of this. Okay. Now this part, how do I calculate? Now this is a little different from a tangent and normal. This is another part of the application where let's say from a lamp which is 4 meters above the ground. Let us say this is my PQ. I have my PQ is equals to 4 meters. Alright, simple enough. Now from this, okay, so this is my pole. Let AB is the man. Okay, so this will become 1.6 meters. So this is my man, this is my pole. Okay. Now, from this, I can calculate that I will have two different kind of triangles. How do I get two different kind of triangles? Let's say, if you look at the question, okay, read it. Let the end of the shadow be R. Okay, if you let the end of the shadow be R, then its distance from A would be the distance from the other PQ, right? So let those two different distances be mentioned over here. So from those two, if that becomes my R common over here, then my two triangles will be triangle PQR and the other triangle will be AB and R. Okay, my two shadows. Okay. Now these two triangles are similar, right? Because if I have a man who is walking at the rate of this, okay, and the shadow is lengthening, then these two triangles will be similar, right? So if these two are similar, then I can have my PQ by AB will be equal to my PR by AR. Okay? But how? How do I take out my PR and AR? I will let my PR is equal to X plus 1. So that will make my AR as 1. Right? If I take one distance as 1 and the other distance will become a variable plus 1. Right? So now from this I get 4 by 1.6 is equals to x plus 1 by 1. If I solve this, I'll get my 2x is equals to 30y. Now, what is the point of all this up till this? Right? Now the differentiating factor. Now what is the change that is happening over here? The change is happening that how fast. If a fast term comes, then it is the gradient over here becomes t, that is time is the gradient. So we differentiate it with respect to t. If I am differentiating it with respect to t, then this AR will become my sum length f. Alright? This I have taken 1 just to get this value. Okay? But if I take this as L, this becomes my 3M. Right? If I solve this, I will get 2 times dx by dt is equals to 3 times dl by dt. That I differentiate both of them with respect to t. Right? If one shadow is lengthening, right, then it is shortening from at the other end. Right? So in both the cases, I need to differentiate with respect to t. After this, what do I get? I solve it from here. My dl by dt is given to me as 30 meters per minute, right? So if I bring it to standard form, I have to multiply by 2 and 3, right? So that will give me 20 meters per minute, right? So this will be the solution for this question. Okay, so this will be my dl by dt that I need to find, and for here my dx by dt is mentioned. Alright, so this is another application. Okay, now moving ahead, you see the solution similar to what I have solved. You see, in this case I have already taken this L. Okay, L is my distance. from one end of the shadow. Okay?
Hi everyone. Now while going through the lecture, if you have any queries, you can post it on our website. First of all, you'll have to go to askIITians.com, and in this over here you'll find ask a question category. When you go to this page, you will have ask experts. In this you select your category of question and post it over here. You can also post an attachment if you have any, or else press get answer, put in your email ID and other details and post it. So guys, that was all about tangents and normals. Now this was the simplest of all three. That is again my opinion. It might be different for you if you like geometry, but tangents and normals are the simplest part. Okay, there would be a lot of questions which would include the topics which are under conic section based on tangents and normals. Now in the next part we'll be studying a section called miscellaneous. Now what is miscellaneous? Basically everything else that has an application based on derivatives. Okay, so we'll be looking at a topic. It's not a very distinctive one, but it's just to basic understanding how in a practical world derivatives are important. So we have miscellaneous coming up, so stay tuned.